Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the GRE Official Guide, the 4th edition. If you do not own this book already, purchase one immediately. You're going to need it. Today is our lesson number 31 and we are on page number 229. Let's take a look at it. Let's take a look at the problem that we have for today. We are given a quadrilateral that looks something like this. This is problem number 3, the very first problem on page 229, and we are given a circle, and inside the circle we have a quadrilateral. That looks something like this. A, B, C and D. And here's the question. In column A we have area of the quadrilateral, A, B, C, D, and we're being asked to compare it with 40. Let's see what we can do. Now, if the book is in front of you and if you're looking at it, or if you're looking at this thing, the very first thing we have to keep in mind when we're taking the GRE, when we're dealing with the geometry problems that have pictures, the very first thing you must keep in mind is that pictures are not drawn to scale. When the GRE people tell us that the pictures are not drawn to scale, that is their way, that is their polite way of saying what you see is not what you are getting, or at least not necessarily what you're getting. What you see is not what you're necessarily getting. We can't just go by the picture. For example, I'm going to give you the two extreme scenarios. Two extreme scenarios would be, I'll tell you what, I was gonna put the two scenarios inside this one, but that will make it very ugly. Let's take a look at them separately. So here's the first extreme scenario. So here's our circle, and if you were divided it nicely into 4 equal quadrants, the quadrilateral that we're looking at could very well be this quadrilateral. In reality, the quadrilateral that we're dealing with could very well be this: A, B, C, D. Oh, I left out the most important part. We are told that the diameter is 10. This is given to us, diameter. This is what they're showing, but in reality it could be this, in which case the diameter is 10, from B to D is 10, from C to the center here would be 5, this would be 10, so it would be half, base times height. Base from here to here is 10, the height here from here to here is 5, we're dealing with 25, half base times height. The area of the triangle BCD is 25, and similarly the area of the triangle BDA is 25. In this case, if it is drawn like this, if the picture that we have here is in fact in reality like this, then the quantity that we have in the first column is 50, and we're comparing 50 versus 40, in which case the answer would have been A. But we don't know, maybe the real picture is like this. Maybe the real picture is something like this. In which case, this area of this triangle, and of course you can bring it closer and closer and closer, asymptotically speaking, the area of this quadrilateral could approach very close to 0, or asymptotically speaking, as I said, it would approach 0. It could be less than 50. It could be anything less than 50. Or if you're clever enough and draw it in such a way, it could be exactly equal to 50. In this case, the answer is A. In this case, the answer would be A. In this case, the answer would be B. In this case, the answer would be C. The correct answer here is D. You can't really tell by looking at it. You can't really tell how the area of the quadrilateral compares with 40 based solely on the way it is drawn. It could change depending on what it is in reality. That's it for today. I'll see you tomorrow, okay? Bye now.